So Unit 10 begins with some work on perimeter, and we're going to get into various aspects of two-dimensional and three-dimensional figures during this unit. So one thing you'll notice is that we're going to come back to some of the old things that we've studied throughout the year on a new topic here. So you'll see things like our trigonometry come up. You'll see things like Pythagorean theorem, distance formula, various ways to calculate measurements. So while it will be some new topics, it will also be revisiting some old ones. All right, so starting off with this first section here, determine the length of side AD. What we want to do to calculate the length of side AD here is to get this right triangle established. So it's often a good idea to drop an altitude down like this one here. And so if I want to solve for AD, I can put an X in that spot. And then we can take the rectangle and translate the 8 across. We have an 11, we have a 17, so if I subtract those two segments, I know that I have a 6. And so Pythagorean theorem would tell me that 6 squared plus 8 squared equals x squared, and x comes out to 10, so that would be the length of AD. AD equals 10. All right, so the perimeter of ABCD, we're going all the way around the figure now, and I actually have all the information I need. It's a 10, an 11, an 8, and a 17. You want to ignore the 8 in here because that's an interior segment, so the exterior segments add up to a total of 46. Okay, so number 1C, if the enclosure is to be surrounded on all sides by fencing that is 75 cents a foot, well, let's just take the calculate the cost by taking that 46 feet we just got and multiply it by 0.75, and so our total is $34.50. All right, so hopefully nothing too bad about that one. There's not, if we have straight line segments, we're really just going to try to calculate the length of each one in some fashion or another. So exercise 2, parallelogram EFGH has vertices as listed, so you should draw them on your grid the same way I have them on mine. And we want the perimeter of EFGH to the nearest tenth. Well, these horizontal segments on the grid are easy to do. They're just 7 units each. You can just count them. So all I need to do is figure out one of these sloped segments, and then I'll be able to double that, and I'll have my perimeter. So the distance of EH is going to be the square root of the vertical and the horizontal distances added together. So the vertical distance goes from -3 up to +7. So that vertical distance is 10 units, and the horizontal distance is 4 units. Okay, and that's again I'm just making a right triangle going up and across between 2 points. So that's 100 plus 16, it's square root 116. And so to the nearest tenth, that comes out to about 10.77. So I have 2 of those, I have 2 sevens, the perimeter in total comes out to 35.54. Just taking the 2 sides that we were able to count horizontally and the 2 sides that we needed distance formula for. All right, next page. If we're trying to calculate perimeter, we're just, like we've said several times already, we just need to determine all the lengths of all the straight lines. So in some cases, that requires some trigonometry. So looking at example 3 here, give it a try before you watch me do it, and see what you come up with. All right, so I need to solve for both of these missing sides. So let's make one of them x and one of them y. And from the 32, if I go across, this is my opposite side. The 12 is my hypotenuse. So if I'm solving for x, I'm going to have a sine equation. So sine of 32 is equal to x over 12. So x equals 12 sine 32. And that's approximately 6.36. All right. And then if I'm solving for y, that's my adjacent side. So I can do cosine of 32 equals y over 12, and so y equals 12 cosine 32, and so I have a total of approximately 10.18. So those 2 lengths added to the 12, perimeter comes out to about 28.54 feet. So trig will come into play several times throughout the unit. All right, in exercise 4, a regular pentagon is drawn such that the distance from its center point to any one of its vertices is 5, so that's this AC segment. Point B is at the midpoint of AD, and CB has been drawn. All right, what is the measure of angle ACB in this diagram? So that's this angle right in here. Well, in a regular polygon, all of those segments drawn to the center, those are equal in length. And so triangle ACD here is an isosceles triangle, and angle segment CB then would bisect both segment AD and angle ACD. So central angles all the way around this thing would be 360 divided by 5. We have 72 in each one of them. So if I go all the way around this figure, it's 72. When I get to this one, I'm just going to split it, 36 and 36. And so that's angle ACB. To determine the length of side AB, and it wants us to leave our answer unrounded, well, the length of AB, that's this segment right here. So, and because I've split this with a perpendicular, I know that I can do opposite here and hypotenuse here. So that's a sine equation. I can write sine 36 equals x over 5. And if I want to leave it unrounded, I would say that AB then, which was my x, is equal to 5 sine 36. All right, and then the perimeter to the nearest tenth of an inch, well, if AB was 5 sine 36, then AD would be 2 AB segments, which would be 10 sine 36, just doubling the 5 sine 36. So to get the perimeter of the pentagon, I have 5 sides, each of which are 10 sine 36. And so that comes out to about, the nearest tenth of an inch, about 29.4 inches. All right, so perimeter problems are not bad if you can remember your strategies, largely for right triangles, but for distance formula and other calculation methods as well.